All right, you guys, let's continue our discussion about solving logarithmic and exponential equations. Let's take a look at our next example. So it says solve the natural log of x equals the natural log of x plus 6 minus the natural log of x minus 4. So the first thing that I want you to do is identify how many logs you see in your problem. So for this one, we see 3 logs. We see 1 on the left and 2 on the right. So right now, we don't have any rules that help us solve logs that have more than 2 logs. Either the logs need to be on the same side of the equation or different. So what we need to do is use a combination of the things that we know so that we get a problem that either has 1 log or 2 logs. So the first thing I'm going to do, I'm going to combine the logs on the right side of my equation using log properties. Okay. So because these are the same log, and they have the same base, and they're being subtracted, we have a rule that says log base A of m over n equals log base A of m minus log base A of n, which tells us if we have a quotient of logs, they can be separated by subtraction, and if they're being subtracted, they could be condensed using division. So I'm going to combine them. So first, let me write my problem. All right, then the logs on the right, I'm going to combine them from left to right. So I'm going to combine them using division. Okay, now you see that I have 2 logs, and they're on separate sides of the equation. So now I can use our rule that says log base A of m equals log base A of n, and we have m equals n. Okay, so I can drop the logs and set their arguments equal to each other. So I have x equals x plus 6 over x minus 4. And I can solve this. So I'm going to cross multiply. I'm going to put the x over 1, and I'm going to cross multiply from left to right. So it's going to give me x times x minus 4 equals 1 times x plus 6. All right. I'm going to multiply the left-hand side together. Okay. Once I multiplied the left-hand side together, it created a quadratic. So now I'm going to put my entire problem in standard form. So I'm going to move what's on the right to the left. Okay. Since this is quadratic, you can solve it any way you'd like. You could factor it, you could use completing the square, you could use the quadratic formula. I'm going to factor it. So I'm going to create 2 sets of parentheses. X is going to go in the front. And I need factors of 6 that are going to give me 5. Well, that's 1 and 6. I need a negative 5, so the 6 is going to be negative, and the 1 is going to be positive. Now I'm going to set each one of those factors equal to 0. And I'm going to solve for x. Okay, so I have 2 answers. Now, before I can accept them, remember, you have to check your answers, okay? So let's check the first one. So if I plug in negative 1 into my function, all right, so let's do this really quickly. All right, so let's plug in negative 1. All right, so when I plug in negative 1 here, and negative 1, and negative 1, okay, that gives me negatives in my argument. So the natural log of negative 1 you can't have. The argument of your log function cannot be negative. So automatically, I have to throw out x equals negative 1. Okay, so let's try that again, but let's try it for 6. So let me blank out our x's again. All right, so we're going to plug in negative 6, or positive 6. All right, and for x, so we have the natural log of 6. Well, that's positive. That's okay. We're going to have 6 plus 6. That's 12. That's okay. And we're going to have 6 minus 4, which is positive 2. And that's okay. So our only answer for this problem is x equals 6. And x equals negative 1 would be considered our extraneous solution. Cool.